Okay, we're looking at trig identities here, and what I notice here is that I have differences of two squares on both top and bottom. And as it turns out, if I take the difference of two squares on the bottom first, I'm going to get the first one squared minus the second one being squared, which is going to be tan squared theta. And the first one squared plus the second one being squared, tan squared theta. And I can see that these two cancel, so that will actually save us some time. So we get 1 over 1 plus tan squared theta. That's right here. Of course, 1 plus tan squared theta, this is a Pythagorean identity, just like cosine squared plus sine squared equals 1. If I divide through by cosine squared, I get 1 plus tan squared equals secant squared. So this is the same thing as 1 over secant squared. So that's also the same thing. 1 over secant squared, that's the exact same thing as cosine squared theta. So we know that one's there. And once again, with the Pythagorean identity, if I subtract sine squared over, cosine squared is 1 minus sine squared. So E is also the same thing. A is the only one that's not equivalent.